What's up? Welcome to Backend Stuff. I'm Jacob Litzo. Today we are going to interact with the database for one of our Ecto Schema tests. The most common use case for using Ecto Schemas is the easy interaction with the database. So let's go ahead and open up our project, Real Deal API. And if you haven't been following along on this project, you can find the GitHub repo in the description below. Now, if you remember when we created the account schema, let's go ahead and open that up. We made the email field a unique constraint. And we also did in our database migrations. So if we go to our migrations and pull up account, you see that we have a unique index for our email field. Now, the unique constraint is actually handled by the database, not our change set. So why add this to our change set? Because it adds a hidden list of maps with constraint info on the change set to let Ecto know that if the database returns an error for a unique constraint on the email field, instead of raising the error, it should add the Ecto constraint error to the list of errors that is returned with an invalid change set. So if we open up our terminal and let's cd into our project, mine is in documents, develop, BS, and then Real Deal API. Let's spin up the Elixir shell. So IEX space dash capital S mix. And what we want to do here, I just want to show you the constraints that are added from adding our unique constraint to the pipeline in our change set function. So let's just go ahead and alias our account schema in so we don't have to type the whole path every time. So we're going to do real deal API dot accounts dot account. All right. And then if we create our change set, let's just save it to a variable called change set, and then we'll set that equal to our account dot change set, and we just need to pass in our empty account struct, and then we want to pass in our email field, and this can be anything. We'll just say email at email.com, and that's a string, and then we want to pass in our hash password, and this can be any string, and then let's close off this map and then close off the function with a closing parentheses. And now when we hit enter, we get a change set back. Now, if we inspect this, we won't see the constraints hidden list because Ecto actually has a custom implementation of the inspect protocol, and it's actually hiding it. But we can still find what the constraints look like. So if we do change set dot constraints, there it is. So we can still pull it out of the struct, the change set struct. And now you can see that the constraint is accounts email index has already been taken, and the field is email, and the type is unique. And so now you can see what adding unique constraint in the schema actually does, and it adds this hidden list of constraints so Ecto knows how to handle that error. So we can go ahead and close out of this. I just wanted to show you guys that. And now, since we can only get this error interacting with the database, we're going to have to write a test that inserts our account struct into the database. And then we have to try to add another account struct with the same email to verify we actually get the error back that we expect. So let's go ahead and open up expand our test folder, Real Deal API, and let's open up our account test file. And we're going to just go into our change set arity2 describe block, and we're going to add a test after the last test that we wrote. So just a little return here, and then we're going to add a test, and then opening quotation marks, and it's going to be, we expect an error back, so it returns an error change set when an email address is reused. Okay, and then we do and end for our test block. Now, we first want to create our first account and insert that into the database. And we can use our valid params function that we have in our, what did we call it? One second. Our support folder, our schema case. So we have our case template here with our valid params function. And so let's go ahead and create a user. So we're going to have a tuple. So when we insert an object into the database, it returns an OK atom and then the object that just got inserted, and we'll call that existing account. And then we'll set it equal to, and I'm just going to tab down or return down for readability. And we're going to pass in our empty account struct, and then we can just pipe in, and we're going to call account.changeset. And then we want to call our valid parameter function here as the second argument passed in. So we can just do valid params, valid params, and then we can use our expected fields with types map that is up here if you don't remember. So we pass that in, and then this is going to return a randomly generated email address and hash password for us. And now we want to pipe in, and we actually want to use repo and insert this into our database. So if we do real deal API dot repo and then just dot insert, and now we're going to pass that into the database. Now we're going to want to create a second account, but use the same email from our existing account object that we just inserted into the database, right? All right, so if we do, let's see, we're going to just save it as a change set here. So let's call this change set with repeated email equals, and then we're going to create another account struct. So we're going to start with an empty struct, and then we can call our account change set. And then in our change set, we're going to want to randomly generate an account again. I'm going to just return down because we're going to get our valid params. And then we can pass in our expected fields with types map. And then I want to pipe into this. We want to replace the email that was just randomly generated. So we're going to do a map put, and then we're going to put it into the email field. And then we want to grab our existing account email. So we're replacing the email that was just generated with our existing account email, because that's the field we're testing our unique constraint on, right? All right, so once that's done, we have our change set now. And we can return down, and we don't want to insert this into the database like we did our existing account, because we actually want to use an assert and pattern matching to catch the errors that we're expecting to get from inserting this into our database. So if we do an assert right here and then opening curly brace, we're expecting to get an error back. And then our change set, the pattern that we're looking for valid to be false. And then we're expecting our list of errors returned. And then go ahead and close those curly braces. And we're just going to set this equal to, I'm going to return down just for readability. Now we're going to insert it into the database here. So we have our change set with repeated email. So now if we do real deal API dot repo dot insert, and then we're just taking our change set with the repeated email and sending it into our database. And we're expecting an error back. So we're expecting this to, pattern match to this change set that is not valid. So this is going to equal true and pass this test, right? All right. We also want to verify that our email field is actually in our error list, right? So if we do another assert and we grab our errors list from right here, and we can actually pull out which field we're looking for, and we're looking for the email field in this key value list. And if it isn't there, we're going to return an error message called the field email is missing from errors, because it should be there. So this should pass with a true. If it doesn't, we'll get that error message. And then we can grab the metadata from the email errors map and make sure that our constraint error is in fact equal to the unique value, because we're making sure, like, we want that our value is not unique. So the error being returned back on constraints should be the unique atom. So if we go ahead and just pattern match our metadata out of our errors list, we can do this with a tuple. We don't need the first value, but we want the second value, which is our meta map. And then we just want to pull that out of our errors list with our email key. Whoop. So there we go. There's that. And now we just do another assert. And then we're calling our meta key value map with our key value list. And we need the value from constraint. And this should be equal to the value unique. And if it's not, we'll return an error message called the validation type. And then we will call our meta list and then validation key here. And so we'll see if our validation is not equal to unique, it'll print out what it is and we'll say is incorrect. So if this doesn't pass, we'll get an error message, but it should pass because we should be getting what we expect. And then we can go ahead and save that. So if we ran our tests right now, we'd get a database connection error with some information about setting up a sandbox for our tests. So let's just open up our terminal. Let's do mixed tests so you can see what happens. Oh, I have a typo. Let's fix that. Oh, the double T there. Okay. So let's go ahead and run our tests and we'll get, yeah, so here we go. We get a database connection error essentially telling us to check some things and then tells us to check out adapters.sql.sandbox for more information. So working against your database and tests is one of the most common places where leftover state changes can cause problems. We managed to avoid issues with our tests on the unique constraint by using randomized data. But even with that, every successive test run is leaving a new row in our database. So to avoid doing that, we can use Ecto Sandbox. And if we go to our schema case template, underneath the using block here, we are going to set up the sandbox, choosing a mode that works well for the limited scope of unit tests. In future videos, we will touch on other modes that require sharing data between tests. So let's just do setup, and then we just need an underscore here. We're not passing any arguments in for our setup. So we just do setup, and we just need to do ecto.adapters.sandbox.mode, and then we want to call the repo and set our mode to manual. So real deal API.repo, and then the mode is going to be an atom manual. And so setting the sandbox to manual sets each test to be able to request its own sandbox connection. That connection will be the same connection throughout the life of the individual test. So every test that uses this case template will now run this code before the test executes as part of the setup steps. So this also applies to tests that don't have any interactions with our database. But fortunately, this is a very fast, lightweight call, and it won't really impact our test suite's overall runtime significantly. So we're going to just leave it here just so it's more easily implemented. So now if we hop over to our test.exs config file, right here, we want to make sure everything is set up for our sandbox properly. So we want to make sure that our repo here is set up to use our ecto.adapters.sql sandbox here in the pool. So we want to make sure that's the same. And then we also want to just verify that our username and password is the same from our dev, because we're connecting to our Docker container. So our username and password have to be the same there as they are in our tests. And then we are almost ready to run our tests after we check this out. We need to update our test to explicitly request a connection from the sandbox at the beginning of the test. This way we don't require extra resources from tests that don't use our database. So let's head back to our count tests. And at the beginning of the test we just added, at the very top, we are going to add a line of code that is requesting a connection to our sandbox database. Okay, so that's ecto.adapters.sql.sandbox.checkout, and then we just pass in our repo. And so that is real deal API.repo. And now this will request a connection to our database and allow us to have a fresh state. So our database will be empty at this point. So this is going to be a blank database. And our database should already be created, but let's just verify that it is. So let's open up Docker first. And we want to just make sure our database is running. If it's not, press the play button. Mine already is. And then we can close that. Okay, so now we're going to drop our test database if it exists. So we're just all on the same page. So whether it exists or it doesn't exist, we're going to all start from the same spot. So if we do all caps mix environment equals test, and then we do mix ecto.drop. This will drop our database if it exists. And then we want to do ecto.create to create our database again. And there we go. And then we want to do ecto.migrate to run our migrations to create our tables. So this would create our account table and our user table. And there we go. So now we're in a good spot. And if we run mix test, we should have 9 passing tests. And there we go. So we have 9 passing tests. So we are getting the correct error back from our change set. So our second account is not getting inserted into our table. So that's pretty sweet, right? So we learned how constraints work with Ecto schemas and how to test them interacting with our database, and how Ecto uses constraints to return database errors to us in our change set. So as always, if you need help or want to check out the solutions, check out that GitHub link in the description below. And if you have more questions or just want to hang out and chat, join my Discord server, backend stuff. That link is in the description as well. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time.